Hello, today we're going to talk about section 4.4. Laws of logarithms. Now, if you want to go to your textbook, you can look up a chart that gives this definition that I'm going to state a little bit better. So you're going to find that on page 354 in your textbook. So the first law that we're going to look at looks like this. So we're going to have three laws. Log base A of A times B equals log base A of A plus log base A of B. Now, we kind of have to think in terms of remembering that these are exponents, right? So if we go back to our exponent rule, what did we do when we multiplied something? We did x to the m times x to the n was what? X to the m plus n, right? So that's basically what you're doing. Multiplication means to add the two. So multiplication means to add the two. So if that's the case, if the second rule looks like this, log base A of A over B, what would that be then? If multiplication is adding the two, what did we find out that x to the m divided by x to the n was? We knew that was going to be x to the m minus n. So over here, we're going to have log base A of A minus log base A of B. So remember, the bases are the same as the original one. The third one that we have, it looks like this. Log base A of A to the C. Now, this is like saying taking a power to a power. So if I have x to the m to the n, what did we do with the exponents when it looked like that? Well, we multiplied them, x to the m times n, right? So over here on number 3, what we're going to do is we're going to rewrite it, bringing the c out front, c log base A of A. Now, it's really important. This one is probably the one that you're going to use the most. So you got to think about this one. This one brings the exponent out front. Here it was an exponent. Now they're going to give some clarifications. A's got to be greater than 0, which we've said on all of these. A cannot be 1, so we did that on all of them. And the A, B, and C that you have up here in the laws are real numbers. And A is greater than 0, and B is greater than 0. Okay, so now we have three laws. Multiplication means to add, division means to subtract, and multiplication is to multiply. So we're bringing the c out front and multiply. So we're going to evaluate. So this one we're going to use condensing. So we have A log base 4 of 2 plus log base 4 of 32 equals what? Okay, so we have them added, right? So what are we going to do when it says to add? So add says you can put it back together as multiplication. So we're going to write this as log base 4 of 2 times 32. So remember I told you before, if you had something like this, we'd want to put equals x. So we have 2 times 32 gives me log base 4 of 64 equals x. So now it's looking a little bit more like what we had before. So what do we have? Base to power, base to power. This is the base, this is the exponent. So 4 to the x equals 64. Now, in order to put these two things together, at least for right now, We said we have to put them in terms of the same base, so this gives me 4 to the x equals 4 to the what? 64 is 4 times 4 times 4. So my answer is x equals 3. Because if your bases are the same and they're equal, then your exponent has to be the same. So this would be exponential form. So at some point went from logarithmic form to exponential form. Okay, give everybody a chance to get this one written down first, and then we'll do another one. Okay, this one's going to be evaluate. So we have log base 2 of 80 minus log base 2 of 5. So now we have subtraction. So what does the rule use for subtraction? Subtraction is division. So we're going to have log base 2 of 80 divided by 5. Now we know that 80 divided by 5 is 16. Good. And then we're going to put equals x. So now again, we've got logarithmic form. Now we're going to put it into exponential form. So base power. So 2 to the x equals 16. So now we want to get these two bases to be set equal, these two things equal to each other, so we have to do something about the bases. So this is going to be 2 to the x equals. So we know 16 is 2 times 2 times 2 times 2, so we get 2 to the 4th. Since we have the same base of 2, then our power is x equals 4. Okay, the next one, evaluate. We have negative 1/3 log 8. So we're going to set this equal to x. So we have x equals negative 1/3 log 8. So we want to take this 1/3 and we want to put it back into the inside again. So this is like law number number 3, excuse me. And we had the c inside or outside. Now we're going to put it back inside. So it looks like log base a of a to the c equals log base a to the a. So the c came out front. So now it's out front, we're going to put it back in. So we're going to write it as x equals log base a of 8. I guess in this one we don't have an a or anything, we just have a blank, so it's going to be 10. So log base 10. If it doesn't have a base and it says log, we talked about that was common log, right? So we're going to make it into base 10, and then negative 1/3 goes in as the power. Because we said we're going to bring the c back inside. So here the c was in front, now the c is back inside. So we have something that looks like this, but that's not completed yet because we haven't solved for x yet. So we have to take it down a little bit more. So this is going to be log base 10, but now this has got a negative, so it's going to be 1 over 8 to the 1/3. So 8 to the 1/3 is the same thing as doing what? Log base 10 of 1 over. Power over root. The top number is the power. The bottom number is the root. So we're going to have what? Cube root of 8. Now we know what the cube root of 8 is. 2 times 2 times 2. So we get log base 10 of 1 over 2. And then you can just put this in your calculator. So when you go in your calculator, let's go 3 decimal places. So you get negative 0.301. Give everybody a chance to catch up to that point. So we're just going to use the LOG button, right? LOG 1/2. Okay, Okay, now we're going to put several within the same example. So this one we're going to call expanding. So expanding means to take it apart, right? So I have log base 5 of x to the third y to the sixth. Now, this is multiplication, so we're going to separate it up, right? So we get log base 5 of what? X to the third, and it's multiplied, so it's going to be plus log base 5 of y to the sixth. So we took multiplication and put it as addition and then left the powers where they were, right? So now this one right here, the 3 is going to come out front. So I have 3 log base 5 of x plus, now over here what's going to happen? The 6 is going to come out front, 6 log 5 of y, because you take the 6 inside. Now, for our notes purposes, let's go ahead and label which laws we used. So to go from this law to this law, that was law number 1. And then to go from this law to this law, that was law number 3. Is everybody okay with that one? Okay, we're going to do another expand. So we get natural log AB over cube root of c. Now there's several different things you can start playing with here. You can just go ahead and separate them out. So we get natural log A, and then what comes next? This is multiplied times b, so it's going to be plus natural log of b, but then we're dividing by this. So minus the natural log of the cube root of c. So we're okay with this step? So now I want to get rid of the radicals. So I get natural log of a plus the natural log of b minus, and now we've got to put this, bring this down. So what did this be? Power and root. So I get natural log of c to the 1/3. Now you'd think we'd be finished, but what do we know about this 1/3? This 1/3 is in an exponent, so where do we have to put it? Out front. So this is going to be the power, and this is going to be the root. So we can go ahead and put it in radical form, or we can just leave it in fraction form. So we get natural log of a plus the natural log of b, and then the 1/3 comes out front, so minus 1/3 natural log of c. So we went from the exponent inside to the exponent out front, so we know that's going to be law number 3. Okay, so everybody okay with expanding? You're just using those 3 laws. So the next one we're going to do is we're going to do the condensing. So condense means to make it smaller. So we're going to start out with 3 natural log of s plus 1/2 natural log of t minus 4 natural log of t squared plus 1. Now, one thing a lot of people get confused, this is not multiplication when it looks like that. So you can't just say this is going to be natural log of t squared plus natural log of 1. So law 3, we're going to bring these exponents out front, or inside, I'm sorry. So this one's going to give us what? Natural log of s to the 3rd plus, and this is going to come out front of the t, so I get natural log of t to the 1/2. And then we have the last one is minus 4 is going to go inside and give us natural log of t squared plus 1 to the 4th. And then if I put these together, then this is going to come together. Multiplication is the same thing as set them side by side. So s to the third times natural log of t to the 1/2 minus would be minus natural log of t squared plus 1 to the 4th. So now how do we put it all back into the big bundle? So this is going to give me natural log parentheses s to the third square root of t, okay, because multiplication is adding them, right? Let me bring this natural log thing down, sorry. So you've got these multiplied times each other. I'm sorry, let's take this line out right here. Let's start from here. The 3 came inside, the 1/2 came inside, the 4 came inside. So now we put these two together right down here. The 1/2 becomes a square root, multiplication. Subtraction then becomes division, so we divide by t squared plus 1 to the 4th. And then we have it all together. Sorry, I added one too many lines. Let's try another condensing one. Okay, so let's start with another one then. We've got 4 log base 5 of t minus 6 log base 5 of s plus 2 log base 5 of r. Now, one of the things we want to take into consideration is first bringing in the things from the outside. So that should be an r on the line. 4 is going to come in with the t, 6 is going to come in with the s, 2 is going to come in with the r. So we've got log base 5 of t to the 4th minus log base 5 of s to the 6th plus log base 5 of r squared. Now, we can reorder this if we want to make it a little bit more clear. So we have log base 5 of t to the 4th plus log base 5 of r squared minus log base 5 of s to the 6th. Now, if they had had a parentheses around this, then we wouldn't have been able to separate that up, okay? So what we're going to do is we're going to keep it just like this because we brought this over. There's no parentheses in there. So this is going to be log base 5. These two are added, so it's going to be t to the 4th and the r squared, because multiply, adding means multiply. And then subtraction, log base 5 of s to the 6th is going to go into the bottom. So just remember, plus, multiply, subtract, divide. And this would be condensed. Give everybody a chance to pitch up to that point first. Okay, the next one we're going to use our calculators on. So on our calculators, we're going to see a button that's going to be an LNX button and an LOGX. So we have, the bases are different in this one. This one's base E and this one is base 10. So we call this natural log, we call this the common log, right? So we're going to have a formula that says log base B of x equals. Our calculators, we can do base 10 and base E on most calculators. Now some calculators can do further, but in our case, we're going to just look at the basic calculator. So how do I get from this to a different base then if I only know how to do these two bases? So what we're going to do is we're going to take and write this as log of x over log of b. So pretend there's kind of an imaginary line between them, and this would give us log of the x on the bottom, and this would give us log b on the bottom. On the bottom would be the b, and the top would be the x. So how does that work? So if I have an example, log base 8 of 5, and that's going to be looking at this original thing, right? So the b is the same as our 8, and the x is the same thing as our 5. So we're going to rewrite it as log of 5 over log of 8. Now, one of the things of the logarithms that you have to watch for on your calculator is this calculator is going to give you log parentheses 5. So you've got to make sure that you put that in parentheses on before you hit divide. So end your parentheses, divide, then we have log parentheses, it puts it up already, and we have 8. So make sure you add these parentheses in so it doesn't screw up your answer. So I got approximately 0.77398. So check and see if that's what you got. Okay, I'm going to give you an example to do on your own then. So it says example log base 9 of 20. So pretend that imaginary line's there, so what are we going to write? Log 20 over log 9. Now I want some of you to try log 20 over log 9, and some of you to try natural log 20 over natural log of 9 and see what happens. You should get, between these two things, you should get the same answer. So log base 9 of 20, log 20 over 9 is going to end up getting us 1.363417. So again, each of these is approximately because you've also rounded some of the other numbers too, right? So when we do that, we get the same answer. So each of these answers for plugging stuff in. So that's all of section 4.4, very quick and to the point. So your assignment is on Google Classroom. Thank you very much. Bye.